Hi, I'm Earl Owen. I teach here at Great Basin College in the Diesel Technology program. And today we're going to learn a little bit about electrical circuits and diagnosis. We've been covering basic theory of Ohm's law and parallel series circuit. You see on the board here behind me, we have a simple series circuit in our first board. We have a parallel circuit here in our second board. And one of the troubles we have in diagnosing circuits in the real world of the equipment is you always can't see the wires, you can't follow them. So learning what we read on our meter gives us an idea, or tells us where our fault is. So the first step is always to make sure that we have our source. So if we look at our source, we got our 13 volts. Now according to Ohm's law, each one of these bulbs, because of the same amount of resistance, should split that voltage. So if I look across the first one, it shows that I have 3 volts. In the second one, I have 3 volts, which indicates that we're not getting full voltage to our bulbs. So that gives us an idea that we have a circuit problem, or a high resistance in this case. So we're simply going to go from R1 on our board to our source, our battery, and we're going to look for resistance. Now we found 7.6 volts. So that tells us we have high resistance in this section of wire. Now if I go between my 2 light bulbs, it should be 0, which we get 0 resistance or voltage dropped between those 2 bulbs. And the second bulb, the ground, should also be 0. Now if we use Ohm's law to validate this, we have 7 volts for our circuit problem, plus our 6 volts with the rounding off, it adds up to our 13. So now we know we have a circuit issue from our battery positive to our very first bulb. And so our circuit right here is dropping 7.5 volts in that section of wire. Where these two are dropping approximately 3 volts per section. These sections 0 volts. This section 0 volts. And so now we know that this wire here needs to be replaced, or we need to verify the connections of that one. So that verifies our first one on our series. Now if we look here at our parallel, you notice we have a bright light, a dim light, and a light that doesn't seem to shine at all. Now the law for parallel is each light should be consuming the same amount of voltage. So again, we still start with our basic process. We verify that we have our source voltage, 13 volts. We're going to go across our first load, and we have our source voltage, 13 volts, so we know that one is functioning properly. The second one, we only have 3 volts again, so that indicates that we have a fault in that bulb. Now we can stop and look at this branch circuit really quick. We can simply go from the positive side to the positive side of our battery, and we have 0 volts. We know that that section is good. We go on the ground side, we have 9 volts. So that shows us an indication we have high resistance from the ground side of bulb 2 to our ground. So that would be the section of wire we're looking at. Now if we move on to the third one, we have 0. Now when we have 0, what we call true 0, when reading a meter, it indicates that we have a lack of current. And one of the rules is we have to have a complete circuit to make current flow. And so now we're looking possibly as an open circuit. We diagnose it the same way. We're going to go from the positive side of the bulb to our battery. We got 0 volts, so that tells us that that section is intact. We're going to go from the ground to our negative, and we find we have 13 volts. So we have an open wire from our number 3 bulb ground side to our ground. And so by simply learning how to take a small voltage reading and using the voltage drop rule, we can determine where the faults are in our circuit, so we can narrow it down and repair the problem quickly. Thanks for watching today.